All right. So you've been working on those two. I know some of you are still finishing it up. I'm going to start working those. This is going to lead us to an important idea. So we want to use the Pythagorean theorem to find the hypotenuse in each of these triangles. So the Pythagorean theorem, I'll have 3 squared plus 3 squared is equal to x squared. And you could call it C, you could call it Bob, you could call it anything you want for the hypotenuse. Thank you for enjoying that. That was a little bit funny. Not a lot. A couple people smiled. So now I need to simplify the square root of 18. The easiest way to do that is to remember perfect square factorization. It's always faster, and this is a pretty small number. I know that 9 goes into that twice. This is 3 square roots of 2. Okay. Same thing on the other one. Be 6 squared plus 6 squared is equal to c squared. So it's 36 plus 36 is c squared. 72 is c squared. So c is the square root of 72. That's probably big enough to where most people will need to do prime factorization to solve it, or to simplify it, I should say. Remember that if you get a perfect square here, you can quit doing prime factors and do the square root. It's 6 and 6. That'll save you some time. So it's the square root of 6 times the square root of 6 times the square root of 2 is 6 square roots of 2. Hey, there's kind of a pattern going there, isn't there? Yeah, and it's not a super hard pattern either, is it? So, everyone please write this one down, and let's do it without the Pythagorean theorem. If I know that this is a right angle, and both of these sides are 27, you probably don't want to do the Pythagorean theorem with that, do you?
No.
No. But what's the hypotenuse?
27 square root 2.
Yeah. It's 27 times the square root of 2. Because these two are alike. Okay? So, now, the other thing I want to point out, what kind of triangles are these? There are two different types. They're right triangles, and they're isosceles. They're right triangles, and they're isosceles. So what do we know about the two base angles? None of the above. What do I know about the two base angles? They are one word, congruent. So, and they have to add up to 90, right? In a right triangle, the two acute angles add up to 90. So they're the same, and they add up to 90. They both have to be 45. So you can call them an isosceles right triangle, or you can call them a 45-45-90 triangle. One of my honor students counted syllables, and she's like, isosceles right triangle is shorter. I'm like, okay. But most people say 45-45-90. Isosceles right is 5 syllables, 45, 45, 90 is 6 syllables, so she said we should say isosceles right triangles. It flows better off most people's tongues than isosceles right. Okay, so here is the rule for isosceles right triangles, or 45, 45, 90 triangles. The legs are congruent. We know that because it's isosceles. The legs have to be congruent. And the hypotenuse equals the leg times the square root of 2. That means if we want to reverse the process, that the leg equals the hypotenuse divided by the square root of 2. This is why we practiced multiplying and dividing by square roots. All right, turn it over. Let's do some examples. We're going to do lots of examples. We'll start with ones that are extremely easy and work our way up to ones that require at least a little bit of work. So for this first one, notice it only gives you that this is 45 and that this is 90. Does it give you the other one as 45?
No.
Does it need to?
No.
No. If this is 90 and this is 45, that's got to be 45. Okay? Hi, Mr. Weedstruck.
Hello.
So if that's the case, what do we know about the two legs? They're congruent. So x is 25. And using that same pattern that we had before, y will be 25 square roots of 2. We just multiply the leg times the square root of 2. Not so bad. That same rule is going to apply on our next problem, but the work of it is a little bit more. Not a lot, but a little bit more. So this is a 45, 45, 90 triangle. This leg is 5 square roots of 3. So how long is the other leg? 5 square roots of 3, exactly. Then what do I do to that? Not what's the answer, but what do I do to that to get the length of the hypotenuse? Multiply by the square root of 2. 5 square roots of 3 times the square root of 2 is 5 square roots of 6. Again, that's why we did all the multiplying and dividing with square roots on last night's homework. Number 3, there's a change. What's different here? We have the hypotenuse. Okay, if we have the hypotenuse, to get to the leg, all we need to do is divide by the square root of 2. And that kind of makes sense when you think about it. A leg is shorter than the hypotenuse, right? Doesn't it make sense you would multiply by a number to get to it? And to go from the hypotenuse back to the leg, we should be dividing because we're getting smaller. These square roots of 2 cancel because the square root of 2 divided by the square root of 2 is what? No. 1. So this is 11, which means that x is also 11. For number 4, we've got a 45, 45, 90 triangle. This leg is 9 square roots of 2, so what do we immediately know with no computations? That one. Which that one? Yeah, y is 9 square roots of 2. How do we find the hypotenuse? So it's going to be 9 square roots of 2 times the square root of 2. And what is the square root of 2 times the square root of 2? 2. Which is true, but it's not simplified.
Oh yeah, that is true.
So the hypotenuse is 18. All right, let's move on. On this one, the hypotenuse is a whole number. Well, that's different. But the way we work it is still the same. When we're going from the hypotenuse to the leg, are we going to be multiplying or dividing? We're going to be dividing. And we're going to divide 24 by square root of 2. Can we cancel here? No. Always look to see if you can cancel first. What are we going to do, Travis? By what? There we go. Square root of 2 over the square root of 2. So that's 24 square roots of 2 over 2. Can I reduce that?
Yes.
Yes. It's 12 square roots of 2. So how do I find the other leg?
It's the same.
It's the same. It's 12 square roots of 2. All right, this one, although it's kind of badly drawn, doesn't look very isosceles, does it? But it says that this is 45 and this is 90, so it's a 45, 45, 90 triangle. Which side do we have? The hypotenuse. I very carelessly didn't label the sides. So what do we need to do to the hypotenuse to get the leg?
The body.
Exactly right. Thank you, Caitlin. Divide by the square root of 2. Can we reduce that? Nope. So we're going to rationalize by multiplying by square root of 2 over the square root of 2. That's 9 square roots of 10 over 2. All right. Number 7. It's a 45, 45, 90 triangle. You got to identify what kind of triangle you have. Which side do we have? We have the hypotenuse. To get the leg, what do we need to do to it? Divide by square root of 2. Can we reduce this? Yes. Don't forget that some of these are easy. So that's just 19 square roots of 3. How long is the other leg?
19 square roots of 3.
19 square roots of 3. Now, what about this one? We don't know it's 45, 45, 90, do we? In fact, I know it's not 45, 45, 90. Because if it was 45, 45, 90 and this leg was 6, how long would the hypotenuse be?
2 square roots
It'd be
or 6 square roots of 2.
6 square roots of 2. Is it 6 square roots of 2? No, it's not a 45, 45, 90 triangle. So what in the world are we going to do?
What's it called? Pythagorean Theorem.
Yeah, we're going to do the Pythagorean Theorem. One of the hard things about math is that when you learn something new, it tends to force out things that you already knew and were good at. So it's 6 squared plus x squared is equal to 10 squared. So it's 36 plus x squared is 100. Subtracting, we get that x squared is 64. It is easy. This is 8. Could we have done that a lot faster? Yes. If you recognize that this is a 3, 4, 5 triangle that has just been doubled. So it's 6, 8, 10. If you know the Pythagorean triples, you can save yourself some time. On a problem like this, if you just wrote x equals 8, went on to the next problem, I'm good with that. Okay? All right. That's it for today's lesson. Got a worksheet for you.